Hi everyone. Another video for testing. So I just gonna wanna show you what blow last time. Remember the little incident, the big boom. That was it. You see, that's the driver, and these tiny creatures, which I showed how I soldered together with that soldering paste and the heat gun, which was very difficult job. And anyway, it blew up, both of them. And anyway, I think the issue about last video is I exceeded the rated isolation voltage and the amps in the same time, because this is rated to 6 amps and rated also for 1200 isolation voltage. So I think I exceeded that. I went to 8 amps last video, and that's what caused this big boom. Maybe because it's also very close together, I'm not sure. But there is another driver. I think Evo should think about that, changing that to a 14 amp and isolation of 2300 volt. I found one today, so we'll see. Anyway, this is the same setup as last time, except that I replaced these two MOSFET SMD drivers, and the other are the same. The clamps are on L3 and L4. L4 for the load. These two probes one on L2 and one on L4. The L4 coil, the last coil there, I'm putting two outputs, one AC and one DC. I'm rectifying this with a full bridge rectifier, and I'm measuring the DC here without load and under load, and also output the AC. The second output is AC going to a 2000 ohm resistor, and I'm putting on that resistor a thermistor, which is connected to this meter to measure exact and continuous instead of this gun. So that's my setup, and right now I'm gonna show you what I have at 60 volts, and this will be like 15 milliampere, and yeah, 0.15, and we'll see how much we're gonna get. This is like 9 watts with 9 watt. So before I put it on, I want to show you the scope here, which I'm gonna go one by one. So this is my the L2. The L2 is about 1000 volt here. I can go to 3000, but it's a different frequency, it's a different setup. And also by the way, the distance between the L2 and L3 is 12 millimeter for now. I made it adjustable also. That thing in the middle, which is written on it, Tesla IVO coil. That's what I called it. And it's 3D printed, and it can turn and change the distance. Anyway, so the L2 spike, the impulse, and then this is the L4 voltage, okay, the pink, and then this is the L4 current with the clamp, and then this is the L3 with the amplification. You will see it now. Alright, so I'm gonna put the system on and you will see. I'm gonna also turn this on. 31 degrees. We're gonna see the thermistor, and we're gonna watch also the DC under load, how much it's gonna be. Alright, go. And that's a 53 kilohertz. And what we have here is 62 volts with 140 milliampere. And I'm gonna run the scope. I'm gonna take it one by one. And so that's the voltage. I'm gonna put it single. I think that the best way to have the spike, it would be in the middle of the between the two cycle. Since this is double that, this should be double that. I mean, the frequency of the output is double the L2. So this should be moved here. That would be the best position to have the spike, to have the best amplification. But I'm not able to do that. When I change the distance between the coils, this does not move that much. So I'm not sure what's the issue, but we'll see together now. Now the temperature rise to 56, and it rises as we speak. 58. Yeah, it's a real power, of course, and it's going banana here. 59, 60, and the voltage on the voltmeter, which I put on the same output but with a rectifier, 134, 33 DC. And okay, so let's see the voltage on L2, L4 is 584 volt peak to peak. All right, and then now we're gonna go and see. I'm gonna take this off. And we'll see. This is the L4. That's the current of the load. Let's measure that. L3, and it's 840 milliamp peak to peak, and RMS 247 milliamp. All right, now let's go see the L3. L3, run it, single trigger, and that's the L3. So let's run it and see the bump live. I'm gonna change, see, this is the bump I was talking about. That's the amplification part here. See, and this is at 51 kilohertz. Now the temperature rise, and it's 80 degrees. Now I'm gonna stop it because this resistor is gonna burn my laptop. And the voltage is 140 DC under load. If I take this off carefully, the DC goes to 270 volt DC. And let's see the change here too. This is now you see the spike, it disappears. It's really minimum, like Ivo says, the spike at minimum now, without the load. Without the load, the spike is like, you know, there is nothing now. And see the input, it's like nothing is going on. And if I put now under load, put it under load, see the temperature went down to 68, now it's rising up. The voltage back is 139 from 270, remember? The input went to the normal, what we had before we under load. And let's run the scope, tick, and the spike is back. And the voltage, let's see, let's take this off. The voltage is back to 830 volt for the impulse, and 568 volt peak to peak. They're all peak to peak. 558 volt peak to peak under load, and the RMS is 187 volt under load. So that's what I have right now. 78. I'm gonna stop that, guys, because it's gonna burn my laptop. And I'm gonna try to change the distance and see again to adjust the impulse, you know, like I said, in between the two cycle. I would like to hear what Ivo will comment on that. Alright, guys, let's see you next time. Bye.